Welcome to the video tutorial on how to create a new configuration with the PeakStore. First, we need to get into the configuration interface. To do this, please select the Configuration tab. There are more tabs on the left and at the bottom. Here you can also change an existing configuration. We now want to create a new one, and therefore select the button New. The unit loads for a moment and then a new tab appears at the top called New. The tab has a narrow frame, which means that all changes we make now affect this configuration. We are now in the first interface called General. This active tab is also marked by a narrow frame. All the basic settings can be seen and made here. We will now give the new configuration a own name. We do this in the Name of Configuration field. I enter Test here. But it makes sense to use names that describe the configuration. For example, the name of a machine type for which this configuration is created, or the sensors used in this configuration. 1N 3A for 1 speed and 3 acceleration as an example. Now we have to choose a configuration type. Depending on the license, there are other options beside vibration measurement, such as balancing for 1 or 2 levels. We will stay with the vibration measurement. Under available channels, you can see the inputs installed in this unit. Below that, the channels used in the current configuration. At the moment, no channels have been assigned, so both the analog inputs and the speed inputs show 0. Under calibration from is the date of the last calibration. New units are of course freshly calibrated before delivery. Additional calibration files can be loaded under Load. For example, for additional sensor sets or if a new calibration has been carried out. In the option field, the online calculation of the spectra and the display of the IP address of the unit, for example for the remote control, can be switched on. In the Trigger tab, you could define a delayed measurement start after a certain time or a certain speed. Under Measurement Control, you can then specify how often this measurement is to be repeated and how much time should elapse between 2 repetitions. Now we want to add a speed channel to our configuration. To do this, we go to the tab Speed Channels. The speed sensor must now be defined here. We add a speed to this configuration by clicking the Add button at the bottom right under Speed Channels. The newly added speed channel appears here at the top. Under Name, any name can be given to the speed channel. As example, the shaft on which the measurement is made. Channel is the input on the unit to which the speed sensor is connected. Pulses per rotation indicates how many pulses the sensor receives per rotation. In case of optical sensors, usually only one, because only one reflex mark is glued. With inductive sensors, screw heads of couplings can also be scanned. Then the number of screws must be entered here to get the correct speed. The trigger threshold can be adjusted if other speed sensors are used. The seed sensors supplied by GFM work ideally with the standard value of 5 volts. These are the speed sensors we use as standard. The first is an inductive sensor with a nominal switch distance of 12 mm. The second is an optical sensor that works with a reflex mark sticker. Next, we want to add vibration channels. To do this, we go to the left to the Vibration Channel tab. Here too, we first have to add new vibration channels to the configuration. We do this by clicking on the Add button at the bottom right under Vibration Channels. The added channel appears at the top. With each click on this button, another channel is added until the maximum number of channels of the hardware is reached. By pressing the delete button under vibration channels, selected channels can also be deleted again. Under name, any name can be assigned to the vibration channel. As an example, the sensor position at which the measurement is made. By default, the sensor names are designated with the channel number. Since we have only defined one speed with the name Drehzahl 1, our reference speed for all channels is this Drehzahl 1. The sensitivity of the sensor is taken from the calibration file loaded under General. We use 100 mV sensors here. The offset is usually 0 for IEPE powered acceleration sensors. The physical unit that the sensor measures is entered under unit. For measuring range, the maximum measuring range is displayed in the physical unit. The amplification of ±10 volt and the sensitivity are calculated. The measuring time is set equally for all channels. You can choose from a pool of 8 measuring times or set the measuring time to unbestimmt, that means undefined. If the measurement time is undefined, the measurement must be explicitly stopped in order to complete the measurement data. We take 40.96 seconds as the measurement time. The sampling frequency can be set separately for each channel by choosing from a selection of 9 sampling frequencies. We stick with the highest sampling rate of 51,200 for the acceleration sensors. The coupling of the channel can be selected separately for each channel between IEPE, AC and DC. Here are some examples of accelerometers we use. The left one is a 100 mV sensor with a resonance frequency of 25 kHz. The right one is a more sensitive 500 mV sensor with a resonance frequency of 16 kHz. Both are designed for a plug connection. A few more sensors. The first two sensors are 100 mV sensors with a resonance frequency of 22 kHz. These sensors are encapsulated and the second can withstand a higher ambient temperature of up to 121 degrees Celsius. The last sensor is again a 500 mV sensor with a resonance frequency of 16 kHz. Now we can calculate characteristic values online during the measurement. To set these, we change to the menu Characteristic by clicking on the tab on the left. Here you can now see the acceleration channels that have been set up. Each individual channel can now be linked to a characteristic value function. DIN ISO 10816 Part 3 is already set here, but other standards of characteristic value calculations can also be used. Under Unit you can select whether the values are calculated in vibration velocity or in vibration acceleration. In addition, a warning threshold and alarm threshold, for example based on the standards, can be defined. I take 2 mm per second for the warning threshold and 5 mm per second for the alarm threshold. The next step is to select a protocol template. To do this, we go to the Protocol Template tab on the left side. Under Measurement Protocol Template, you can select from various templates that you have previously stored. As you can see, we have different types of gearboxes. Your machines or system types to be measured could be stored here. I will now simply select a gearbox with 3 spur gear stages and a power split. Then I activate the automatic sensor placement. This makes it easier to fill out the measurement protocol during the measurement. That concludes the test configuration. Now we save it with the Save button. Make the test configuration to the active configuration with the Activate button. Now you see that the green tick has jumped from WEA to Test, which confirms that this configuration is now active. Now we just go back to the Start interface by pressing the Measure button and wait for the settling process. You will now see the setup acceleration channels and the speed channel. Now the unit is ready for the measurements with this configuration. We hope you enjoyed this video. Thank you for watching.